This is the question asked in today's skillrack daily challenge. In the first line of our input, we are given the value of integer n, and after that we are given n integers as input. So here n is equal to 5, so we are given 5 integers as input. So now for every integer out of the n integer, we have to check whether the binary representation of the integer is a palindrome or not. If it is a palindrome, then we have to print those particular integers. So the first integer is 5. So let us find its binary representation. The binary representation of the integer 5 is 101, and the reverse is also 101. So both the binary representation and the reverse is also 101. So both are same. So this is the condition for a palindrome. So the integer 5 has a palindromic binary representation. So as per the condition, we have to print the particular integer in our output. So in our output we are printing 5. So like this we have to check for all the integers out of n integers. So the second integer is 8, and now again we have to perform the same thing. So first we have to find the binary representation of 8. So the binary representation is 1000. So now we have to reverse it. So the reverse of this binary representation is 0001. So both are not equal. So 1000 is not equal to 001. So the integer 8 does not has a palindromic binary representation. So we are not printing it in our output. So we move on to the next integer. So the third integer is 45. So now again we have to find the binary representation of the integer 45 and then check whether the binary representation is a palindrome or not. So the binary representation of 45 is 101101, and now we have to reverse it. So the reverse is 101101. So both the binary representation and the reverse, so both are same. So it is a palindromic binary expression. So in our output we have to print this integer 45. So in our output we are printing the integer 45. So this is how we should be printing our output. Whenever the binary representation is a palindrome, we have to print those particular integer. So the integer 27 also has a palindromic binary expression, so we will be printing it, and the 32 does not has a palindromic binary expression, so we don't print it. Suppose if none of the integer out of the n integer has a palindromic binary expression, then in those cases our output would be empty. So whenever none of the integer has a palindromic binary expression, then in those cases we have to print -1 as our output. So now let us see how to write a C program for this. So in the first line I am creating two integer variables named n and has palindrome. So initially I am setting has palindrome is equal to 0. So we will be using this variable has palindrome to check whether there is at least one integer having a valid palindromic binary representation. And in the next line I am accepting the value of integer n, and then I am creating a new integer variable named val. So now we have to accept n integers as input. So here we are not going to accept our input and store it into an array. Instead, soon after accepting our input, we are going to check whether it has a valid palindromic binary representation or not. So now we have to accept n integers as input. So I am creating a loop that iterates for n times, and in every iteration we will be accepting an integer using scanf statement, and we will be storing that integer into the variable val. So now we have to find the binary representation. So before doing that, we will be creating some more integer variables which we will be using. So the first integer variable is temp, and I am storing the value of the val into the temp. So temp is equal to val, and then I am creating another integer variable named int, which represents index, and I am initially setting it to 0, and then an array named bin in which we will be storing the zeros and 1. So the size of this integer array is 32, and when we initialize like this, all the 32 integers in the array will be initially 0. And then I am creating another variable named flag, and I am setting it to 0. So first we are going to find the binary representation. So we will be storing the zeros and ones into this array bin. So to find the binary representation, we will be keeping on dividing the integer n by 2, and we will be storing n mod 2 into our array. So here I am creating a while loop, and this while loop iterates until the variable temp becomes equal to 0. So in every iteration we will be dividing the variable temp by 2 and we will be storing temp mod 2 into our array. So in the array I am setting bin of index plus plus is equal to temp mod 2. So after the execution of this while loop, the binary representation, that is the zeros and ones, will be stored into the array temp. Now we have to check whether that binary representation is a palindrome or not. So in this for loop we will be checking it. So to check whether the binary representation and the reverse binary representation is same or not, in this for loop we will be iterating from 0 till index by 2. So that is, we will be iterating till half the length. So the value of index is the length of the array. So from 0 I am iterating till n, the length by 2, and in every iteration we will be comparing the first and last first, second and last second. So we will be comparing those bits. So after the execution of the for loop, if any two bits, that is if the first and last first is not equal, then we will be setting flag is equal to 1. So like this we will be checking all the bits. So first and last first, second and last second, third and last third. So like this we will be checking. So after the execution of the for loop, if the value of flag is equal to 1, then it means that the binary representation and the reverse is not equal. But the same, if flag is equal to 0, then it means that the reverse and the binary representation both are same. So that is, it is a palindrome. So whenever the value of flag is equal to 0, then we print the value of the integer. So we print val, and also I set the value of hash palindrome is equal to 1, because we have found at least one integer which has the valid palindromic binary representation. So this is how we will be printing our output. So finally, after the execution of this I loop, if the integers has a palindromic binary representation, then we would have printed those integers. Suppose if none of the integers has a palindromic binary representation, then we would have printed nothing. So in those cases we have to print -1, and in those cases the value of the variable has palindrome will be equal to 0. So we are checking whether has palindrome is equal to 0 or not. If it is, then we print -1. So now let us check our program with the sample test cases. So this is our sample input 1, and here out of these 5 integers, the integer 5, 45 and 27. So we also get the correct integers as our output. So now let us remove these 3 integers 5, 47 and 25, and let us check our program. So when this is our input, our expected output is -1, because both the integers 8 and 32 does not has a palindromic binary representation. So our output must be -1, and we are also getting -1 as our output. So this is the logic behind today's daily challenge. Thank you for watching.